Give the talk today because she's sick. I'm just filling in. Last April, I gave one of these talks and explained to people what this grant program is that I function under. That for part of my FTE, my full-time equivalent time is pediatric environmental health specialty units. So I'm not going to go over what a PESU is again, but just very quickly, the EPA and the ATSDR, which is a branch of CDC, got together and realized they didn't have expertise in the medical effects, the health effects of environmental exposures, and they wanted to have some consultants. And so every EPA region has a pediatric environmental health specialty unit that's made up of physicians and nurses that are centers of expertise in health effects of children's environmental exposures. And because I am occupational medicine, we do adults too. So one of the things the EPA and ATSDR wanted us to do, these 10 different centers regionally, is teach other healthcare providers about this stuff. Because you guys get to learn it as EOHS students, but doctors and nurses never learn this stuff. So you've got patients showing up in doctors' offices saying, oh, I'm afraid, I was exposed to X, what do I do? And doctors don't know. So this is one of the presentations that I give to healthcare providers on endocrine disruption. And I don't know if you learn about it elsewhere. If you do, you're just going to get the version today of what I give to healthcare providers. So we're going to talk about some major endocrine disruptors, their physiologic and toxic concepts, and how to advise clients, patients, other learners, how to minimize exposure. So let's start with talking about DES. Does anybody has heard of DES? Who in here has heard of DES besides faculty? No, you two have, because you probably know them. So DES was a drug that was used in the middle of the last century to prevent miscarriage. And here's an ad for it. Yes, does flax prevent abortion, miscarriage, preterm labor, recommended for routine prophylaxis in all pregnancies. So this turned out to be really bad advice, a really bad plan. And here's a timeline. It was first produced in 1938. By 1940, it was widely prescribed for women who had threatened miscarriages. And by 1954, clinical trials found it not to be effective, but that didn't stop the prescriptions. 1971 is when it was first linked to vaginal adenocarcinoma in DES daughters, and it was banned. So you went from clinical trials finding it doesn't work up until 1971 when it was finally banned. And these are just different cohorts that were assembled. In 2000, they assembled a third generation of DES daughters. So the women who took it in pregnancy had girls, and then they studied those girls who had girls to see the epigenetic phenomenon. So what happened? I'm sorry, I gotta use this thing because it's a PDF. So what happened was the women who were given DES while they were pregnant, as the female fetuses were developing, the female fetuses were exposed to this very high level of estrogen, because DES was a type of estrogen to support the uterus to not have a miscarriage. When they were born, grew up, they must have had some abdominal symptoms or infertility that resulted in a workup, and were found to have, well, first of all, they were found to have birth defects. So these are the different shapes of uteruses that resulted from them being exposed to DES. So, normal uterus has, but this one looks pretty normal. This one here that has just kind of a normal, here's the vagina, the cervix, and the fallopian tubes. And these are all the different birth defects. Here's a septate. So septums were pretty common. Here's unicornuate, which means it just has like one side developed and then this other side didn't develop. Here's bicornuate, so the uterus actually like develops in half like this. So you can imagine it would be hard to carry a pregnancy to term, so it caused infertility. And they also started discovering this really rare form of cancer, this clear cell adenocarcinoma. It's very rare. And the women who were DES daughters were getting this vaginal cancer. And then there's also, this is just a very simplistic graphic, but New England Journal, so one of the most prestigious journals we have, 1984, look at this breast cancer incidence in exposed versus unexposed. So there was a correlation found between, this is again, DES daughters. So the mothers who took it in pregnancy, the fetuses that developed went on to get breast cancer. And then the male offspring were not immune either to this massive dose of estrogen in utero, meaning during pregnancy. This was a cool study from, and we're talking just 2011, so it's not that long ago. And I'm sorry about the writing, but first generation, okay? So you had exposed pregnancies or unexposed and exposed pregnancies. Exposed pregnancies, so women were given DES, they had boys and girls. Of those direct offspring, 28% had some abnormality, this must be on a timer, of development of the uterus, fallopian tubes. 3.5% of the boys had hypospadias. If you study endocrine disruption in males, it's really interesting. You got to learn about hypospadias when the urethra actually doesn't come out at the tip of the penis. It comes somewhere down the shaft or in the scrotum. It actually is fixable. It's very easily fixable, but it's really important for uncircumcised boys. Sometimes will present to the doctor because the parents will know that the urine is just like spraying out instead of coming out in a stream. And that can mean that there's hypospadias. So anyway, these girls who then successfully had boys, 8.2% hypospadias. That's a lot. So you had a DES grandmother, had a girl who had a boy, 8.2% of them had some type of hypospadias. That's crazy. These are all 0, 0, 0. So one of the things that this showed was that not only the person being exposed was affected, their offspring was affected, their grand offspring was affected. And then you look at male effects. I actually have a whole talk on male effects of endocrine disruptors because I find it interesting because it's so ignored. You always talk about infertility in women. This was a case that you might learn in Linda's class. I don't know if she has one of the Dr. Hinkamp that does this lecture, but in 1977, there were male pesticide workers. They were sitting around talking. Wow, I'm trying to have a kid. Can't have a kid. Oh, I can't either. Oh, I can't either. They went to a doctor who was like, what's going on here? And they were all worked at a facility that used dichloromethylpropane. It's a nematicide. It had already been shown to cause sterility in rats. And these workers worked at a North Carolina DBCB plant where they mixed, diluted, repackaged pesticides from primary manufacturers. And it was 5 men who noticed difficulty fathering offspring, and they all had either oligospermia, which is a low sperm count, or azoospermia, which is no sperm. So, and for these types of evaluations, it's you just put the ejaculate under the microscope and you start counting sperm. So they put it under there and there were no sperm. So that was really dramatic and horrifying. So then they expanded it to 25 workers. 11 of the 25 had low sperm counts. 9 of the 11 longest exposed had no sperm. They did testicular biopsies. They had no stems. What do you call this? First generation. Anyway, spermatogonia. So they weren't going to develop into sperm. They had poor recovery. And this is it just shows you normal sperm count when you just put it on the microscope, and here's a low sperm count. And they also had a normal sperm which you can also see under the microscope, where they've got like these bifurcated tails, they've got double-headed, they couldn't swim right. Those are all measures that go into a semen analysis. So why did they let Hawaii use it 10 years after the EPA banned it? Because people like pineapple. So it was one of those industry affecting EPA where, you know, if you don't let us use this, it will wipe out our state's production of pineapple. So they got to use it for 10 more years.
When they stopped using it, did it wipe out their?
I'm still eating pineapple. I have no idea. Yeah, good question. Probably not.
Right.
It's like if we stop using fossil fuels. Okay. So this follow-up continued, a total of 107, 13% of them, no sperm. 17% severely low sperm count, 16% mildly, and affected up to 8 years after. Motility and morphology. So that's how they swam, how motile they are, and morphology is the shape of the heads and the tails were affected up to 8 years after exposure. There's another case of ethylene dibromide in 1987 in the papaya fumigation industry in Hawaii. They had decreases in sperm count and issues with the motility and viability. Ketone was chlordicone, 1974, 57% had low sperm counts. And again, you see these were happening in the 80s and the 70s, and the study came out in 2007. So it's really something in the last 20 years that's picked up in popularity as a topic of discussion. So what we're talking about are chemicals that are considered endocrine disruptors, EDCs, which the EPA did define in 1997 with this long description about anything that interferes with basically hormone metabolism, or in simpler terms, a substance which interferes with natural hormones. And these are all the organs in the body that make hormones: pituitary, pineal gland, thyroid gland, adrenals, pancreas, ovary, and testicles. So, and they're all in very sophisticated feedback loops. So it's a really delicate balance, and it's incredibly cool and sophisticated, like I said, because the thyroid gland not only makes thyroid hormone, it makes thyroid stimulating hormone, which reads when the body is low in thyroid, TSH goes up to tell the thyroid to make more. And that's the same with estrogen and testosterone. Estrogen will tell the body to make follicle stimulating hormone, which makes the ovary release an egg, and then there's feedback to say, okay, that's enough, calm down. So and so you can see where a disruption in any step can wreak havoc. So how does this work? It looks like what happens is these these chemicals are acting like hormones. They look like hormones. The cells are reading them as hormones and letting them into the nucleus. So this is a steroid hormone. It's just a typical like testosterone. It gets into the cell, and then there's a receptor protein on the nuclear membrane. You guys can see me. So this is where the problem lies. So this receptor protein will look at DES and say, oh, you look like regular estrogen, so we'll let you in. And then there's this DNA and mRNA process that then makes a new protein, which may be like thyroid stimulating hormone saying, make more thyroid hormone. So it's like, oh no, actually it's not, the body doesn't need to make more thyroid hormone because it's a chemical that's telling the cell to make more hormone, and then you get hyperthyroidism caused by this chemical that screwed up the system. So you got thyroid hormone, progesterone blockage, anti-androgen, interference with estrogen receptor pathways. They're now endocrine disruptors that have been found to be obesogens. So you got chemicals telling your cells to save more calories. And so there's this amazing photo of a mouse fed bisphenol A in their diet, and a mouse not fed the exact same diet, and this BPA mouse is much larger. So obesity is now considered part of the hormone pathway. So I divide this talk up into, I use this paradigm that you learn about in risk assessment to go through how we assess endocrine disruption. So there are, of course, industries saying endocrine disruption is not a thing, the doses are too low, this is not happening. So we go through these steps of the step one that in this causality are there health trends in the general population? So look at the epi, look at the ecologic studies, are there trends? Then a part of exposure assessment is, okay, well, so hypospadias is going on, but what's your proof that we're exposed? So you look at exposure studies, and then, okay, so we're being exposed, but what's your proof that this chemical is bad? Do you have any evidence that the chemical is bad? So you look at your toxicity studies and dose response, and for those who've taken risk assessment, this will be familiar. And then the last step is you put that all together, and is there enough evidence to conclude that DES causes adenocarcinoma of the vagina? So we'll just quickly go through these steps with endocrine disruption. So let's first look at epidemiology, looking at prevalence and demographics. So are there health trends in the general population? And this researcher at UCSF, Tracy Woodruff, she is awesome. She put together the study that now it's 2010, it's been a while, but she put together all the literature on endocrine disruption that caused reproductive disorders and made this table, which is really useful. This arrow is conditions that are going up in prevalence. So testicular cancer is going up, childhood cancer, autism, ADHD, cryptorchidism, which is when the testicles don't descend into the sac. That is also an estrogen dependent process. Congenital hypothyroidism. Those are all going up. These are all going down, or function is going down. So you've got infertility that's been going up 200% in women less than 25 years old. So it's not just that we're all old ladies trying to get pregnant, although there's a lot of us. Less than 25-year-olds. Prematurity, preeclampsia, which is high blood pressure pregnancy, type 2 diabetes. So you have diabetes, this one is a hormone, so that's susceptible to hormone disruption. Age of onset of breast development, menstruation. Look at the sperm count here. 1% decline per year since 1931. So people who study male fertility are panicking. The sperm count is really going down. And the serum testosterone levels, 1% decline per year. So this is a big problem. Here's some other epi. Oh, I'm sorry, I keep moving away from the mic. I just realized that. Sorry about that, you guys. Trends in hypospadias. Once again, I told you what hypospadias is. This is an old graphic. I couldn't find anything more recent, but it just shows in industrialized countries. The green boxes are a study in Atlanta. Nationwide is the X's. So this is the increase in incidence of hypospadia. So why are all these boys being born with this abnormality? Here's, look at this sperm count. Once again, like I said, there is panic going on in the Western world in the decrease in sperm count. And so much that Shauna Swan, who is another amazing reproductive health researcher, she published a lay book last year called Countdown, and the book is about all the environmental exposures that are affecting sperm count. And I haven't read it, but apparently written in a way that, you know, the layperson could get through it. She's done a lot of this work herself. I mentioned cryptorchidism, which is undescended testicles, another thing that's easy to fix. Fortunately, because as you may know, testicles cannot, they won't function if they're in the abdominal cavity at that temperature. They need to be outside the body. And here's the increased incidence in cryptorchidism. So why aren't testicles descending as much? All right, so that was the general epi. So we see there are trends. There are trends in bad things happening, which you learn in epi or biostats means nothing as far as causality goes. Let's prove that people are being exposed. So I just have a couple slides on that. I think I showed this last spring because I showed it in a lot of talks. It's another study by Trace, no, it's Amizoda. Yeah, Tracy Woodruff. So she was just drawing blood from pregnant women. She had a cohort, pregnant women, drew their blood for all kinds of chemicals. And here is her results. So each column is a different pregnant person, and each color is a different chemical that they're exposed to. So this is phthalate, so it's a plasticizer. The green is polyaromatic hydrocarbons. We should stay over here. The orange is the polybrominated diphenyl ether, so the stain guards. Blue is organochlorine pesticides, mostly that have been banned but are still in the environment. Metals are in the gray, which would be arsenic, mercury, lead, and call it back later. And then what's cotinine? That was the only one that didn't appear in every single person. Yeah, it's the metabolite of tobacco. So if you want to study whether people are smoking or exposed to secondhand smoke, it's cotinine instead of a tobacco level. So that was the only one that wasn't in every single person. So we're doing an okay job at our public health outreach about smoking, but not everything else, because every other one of these was present in every single participant. One more exposure assessment slide that I think is also really cool is, we used to think the placenta protected the fetus, that nothing could get through. It was in this nice little sterile bubble. But now we know that most chemicals do cross the placenta. And the way you find out is you take blood from the umbilical cord. So blood from the umbilical cord is going right into the baby. It will tell you what the baby's blood level is. And it's really easy to collect. You don't have to stick the baby. The baby is born before the placenta detaches between 5 and 20 minutes later. You cut the cord and just unclamp the cord and hold a test tube under it. So it's a very cool way to easily get a baby's blood levels. So they did this. Every black column is a mother and every blue column is the baby's cord blood level of perfluorochemicals. So these are the stain guards. And what you see is not only are they present in every mother and every newborn, but the levels are higher in the newborns. So not only does the placenta not protect the baby, it concentrates, in some cases, it concentrates the chemicals. So I think we move on. No, we're still on the exposure. So we know there's exposure to some of these chemicals. There are studies. These aren't biomarkers, but these are surveys of how much people use personal care products, because personal care products have a lot of endocrine disruptors in them for their scent, for the they make like nail polish more viscous, the plasticizers, they make makeup last longer. So there's two different classes. The diethyl phthalates are the scent, and the other two are the plasticizers. So they interviewed women. They use an average of 12 personal care products per day. Teenagers use about 17. Here's another exposure study. Antonia Califat, she's awesome too. In 2015, she, the N. Haynes from 2003 to 2010 did these measurements. So 97% of us have benzophenones. Those are, you can see those ingredients on some personal care products. Triclosans, 75% of people, that's a antimicrobial that's in toothpaste and other things, and it should be mostly removed from toothpaste now. The parabens, I don't know if your sunscreen, you notice that it used to have a lot of parabens, and now it'll be advertised paraben free. And this bottom is phthalates. The last one is I'm not sure what DIB is, whether it's a bisphenol or a phthalate. Anyway, we're all full of all this stuff. So now we've got the trends in issues of infertility and hypospadias and sperm count and breast development early. We've got these studies showing us we're all exposed. So that still doesn't prove anything, right? That still could all be ecologic. We don't have proof yet that these are a problem. So let's look at the toxicity profile. Where is the proof? Toxicity profile includes animal studies, the epi studies that look at associations, the epi studies that look at dose response. And so I'll just give you a few examples of those. So this is a really busy slide, but it does look at, it was just published 2018, Environmental Health Perspectives, phthalates, so that's a plasticizer, bisphenol A plasticizer, and puberty timing. And I just highlighted, so on the biomarker on the left is the list of all the measurements they did of associations with, okay, phalarchy is breast development. So this is in girls. Then there was a whole table for boys, which I might have next. But so this first bunch is all the chemicals and their association with breast development. The next one is puberty is pubic hair development. And the third one is menarche, so menstruation starting. And it divided it into the weight because adipose tissue makes estrogen. So you have to control for obesity in these studies because the people who are obese have higher levels of estrogen, so they may have more estrogen outcomes. So in the normal weight girls, BPA was associated with early development of pubic hair and earlier menstruation. So that is a study of causality. This one, this is an amazing study from 2008 that accumulates all the studies on pesticides and their endocrine disruption. So I did a screenshot of the first part of one table, and it's only the A's and the B's and the beginning of the C's of the hundreds of pesticides and the studies that have been done showing causality between exposure and outcome. So we'll just take, for example, one that might be familiar. Is there a familiar one on here? Not really. So if you take aldicarb, it's an insecticide. It inhibits estradiol and progesterone activity and shows weak estrogenic effects. Atrazine, it's an androgen inhibitor. So those are the male hormones. Okay. It disrupts the control of LH and prolactin, really important hormones. So there is evidence of toxicity of these, of a lot of the endocrine disrupting chemicals. So we showed the trends in the population. We showed that we're all exposed to these things. We showed that the chemicals are bad. They have been correlated with health outcomes. So is there enough evidence to conclude that endocrine disruptors are causing adverse health outcomes? Well, let's see what the experts say. So back in 2008, the Endocrine Society of America, so all the doctors and researchers that do hormones, they came up with a scientific statement that said the evidence for adverse outcomes is strong. And there's mounting evidence for other effects besides infertility, cancers, and malformations. So that was a pretty big deal back in 2008. And then they came back in 2015 and they said, we've reviewed 1,300 more articles that have been published since we first put out our statement. And now we say that there's a strong basis for concern about the risk associated with exposure, especially at low doses. You people that say these aren't doing anything because the doses are too low. We need new studies. But look at that last bullet. Scientific knowledge since 2009 identifies EDCs as contributors to increases in the incidence of all these things. Infertility, neurodevelopment. So we're talking about, there are studies about behavior in children, aggressive behaviors, thyroid dysfunction, obesity, autoimmune disease like lupus, MS, diabetes, and hormone-sensitive cancers. So that was a very strong statement in 2015, basically putting to rest any arguments that these EDCs are not doing anything. There's a whole endocrine disruptors program at the NIH that lists what the NIH says. These are endocrine disruptors on this list: dioxins, these organochlorine phosphate pesticides, PCBs, DDT, phthalates. I don't know why DES is not on there. I think maybe they weren't dealing with medicines. And then I'll just go through a couple interventions to decrease exposure. Is Sonia in here? I just met with Sonia earlier and we talked about the frustration for environmental practitioners to, the main thing that we do to decrease exposure is tell people to change their behavior. Do this, don't do that, don't eat fish with mercury, don't use personal care products, and that gets a little frustrating. That doesn't stop the EPA from funding a lot of those types of studies, which is what I'm working on with Sonia, of how to get people to modify their fish consumption so they decrease their exposure. What would be a more public health approach to decreasing exposure besides just changing your personal behavior? Yes, eliminating the chemicals. So you could use the hierarchy of controls for that. You could eliminate, you could substitute, you could put engineering controls so you don't get exposed to that particular chemical. But anyway, I'm going to show you the personal behavior recommendations because they're kind of fun. I don't follow them all myself. Here's one. The Environmental Working Group puts out the Dirty Dozen every year, which is the 12 fruits and vegetables you should avoid, and the Clean 15. So they put 15 that you can eat. So each year, based on pesticide content. Strawberries are always at the top of that list. I love strawberries. I don't always buy organic. They're expensive. So, but what we do tell people is if you want to do some avoidance when you're at the grocery store, and there's an app for this, you know, you could buy, if you're going to buy the top 3, make them organic. You know, if you're going to buy strawberries, spinach, and kale, choose the organic ones. Right. Does anybody know about this Skin Deep database? So this is very cool. Environmental Working Group has a database of personal care products. So if you want to look up your own shampoo, your own moisturizer, whatever, it'll tell you the safety. And I just plugged in shampoo on here and I got 4,548 products. So it's a massive database. So there's an app for that too, if you're at the pharmacy and want to buy your personal care products. Our website, our PESU website here at UIC, we've got some steps to reduce exposure in the home, and it's got a nice little graphic of the different rooms and where the exposures might be and what you could do, increase ventilation, etc. And we've also developed this guide for communities because we'll get questions to our PESU is we educate healthcare providers, but we also reach out to communities, and we'll get community members saying, oh, my kid's going to school and there's 3 cases of cancer and it's got to be some environmental problem. Or my child has autism. We live down the road from a landfill. I mean, these are actual calls that we get. What do I do? And so we put together this booklet that shows them how they themselves can find out what their exposures are based on public databases. You know, if you're worried there's something in your air, your water, the soil, that stuff is out there. And so it just goes through all the different resources online. And the last page is this quick resource guide that shows you all the different ways you can find what's in your environment. And the rest is about PACES. I already told you about that. We actually have a team all over Region 5 of different doctors and nurses, mostly doctors, that are involved in this outreach to other healthcare providers and communities about children's environmental health. All right. Thank you. Questions? Any questions?
I had a question.
So thank you. I guess I was just curious, I think it was like a slide after the Hawaii slide, you were talking about the studies where they checked 20 or 30 years later. How did they do that? Did the people like get?
No, it was published. It was published 20 to 30 years later. I think so. I'm not sure. I'm not sure actually, but yeah, they can track people down nowadays, but I'm not sure. Sorry about that. Any other questions? All right, we should eat leftover pizza.
So you spend a lot of your time in the country trying to translate
what we have. If the public, yeah, I mean, this was a great, amazing class. Thank you for doing this, but where's on this slide? What do you,
I wouldn't use those words with the
no,
public.
I was saying, how would you, like, so for instance, right? These are all students, we all have to figure out how to translate our scientific knowledge into lay terms. This is actually a great example. This study, how do you then take this information and say, hey, patients, you might want to, like, how do you translate all of this into messaging for the public, for patients, multiple different audiences?
Well, I'll say there's a lot of research funding to figure that out. including one that I just got that I was mentioning with Sonia, and half of the study is finding out from people who fish recreationally on Lake Michigan, how to find out how they want to get information about PFAS. So the funders clearly said, we don't know how to reach these people about PFAS and fish. So go ask them, go find out. So we are. So I think there's a lot that's not known. Now, when I did my talk last April on our mercury study, we did, that was also a question. We used text messaging to Chinese, Korean, and Vietnamese people who ate fish in the Chicago area to teach them, and women of reproductive age, how to choose this fish, not that. And we used a behavior change model, which I've done some reading about, and in public health, hopefully you're learning it in some of your IPHS classes. There are different models about how to get people to change their behavior. Now, as a physician, I've spent a career telling patients what to do and expecting them to do it. And that's what I put in our first application for this funding. And they said, you don't know what you're talking about. You need to get a behavioral health person to use a model that puts in domains that help people change behavior, because you just telling them to do it isn't going to work. And those models include things like you're asking, how do you do it? I mean, these actual models say, recognize who the leaders in the community are, recognize the normal behaviors. Somebody who eats fish every Chinese New Year is a buffet full of fish, and you say, oh, you shouldn't eat any fish on Chinese New Year. No, they've been doing it every year of their lives. That's what their mother fixes for their grandmother fixes for them. There's fish also has cultural meaning. It means abundance. So that's really culturally insulting. And not only doesn't it work, it's really insulting to then not recognize that importance. So you recognize the norms in the community, you go to the elders, you work with the elders in the community who are making those types of policies. Another domain is self-efficacy. So your self-confidence that you can do it. You build up people's confidence. And if they stay at the beginning, I'm not going to be able to do this, then it's not worth it. I mean, we use that in quitting smoking too. You do not try to get someone to quit smoking unless they are ready to quit smoking. Your chances are close to 0% that they will quit. Just like what I said, the doctor saying, you should quit smoking. There are stages. There's a preparation stage where they're thinking about smoking, and then they're ready to quit smoking, and then they pick a date. So those are all different stages. And if you're not ready to pick a date, you're probably not going to quit smoking. So it's the same with other behavior changes. Long answer to a short question.
You pushed us to say that elimination of these would be the best, in terms of hierarchy controls and to prevent exposure in the first place. How do we, as public health people, push for that? What are the best ways for us to get involved? I'm very familiar on the occupational side, as are some of the occupational students, that when there's a proposed rule for OSHA, we can go in and leave comments and we can say why it's important. Is there that opportunity for these sorts of regulations?
Well, I know, see, that's interesting, because as a state employee, we cannot lobby for particular students can. We can't lobby for particular legislation.
Sure.
So, but you can, yes. So EPA, just a sec. So OSHA has the comments, EPA does too. So EPA will put up rules, And I think what one thing people don't know is that they actually take those comments seriously. So when they put EPA proposes a rule, they have well, first of all, they open it up for public comments. They have community meetings around the country where you show up and you read your statement. You can also email them in and they'll get 12,000 comments. They have to go through all of them before they promulgate the rule. And they have to, so if a bunch of comments say, this is a problem, this is a problem, this is a problem, they have to address them. And then they publicly say how they address the comments. So that is kind of cool, kind of democratically built into the process. So you do have a chance for those rules. And of course you have a chance with the way you vote, who you want in charge. There's a huge difference in how the EPA functions based on who is in the White House, because they will appoint somebody to head the EPA that says, well, we have all these rules, but we're not going to enforce them. I'm not putting any funding into enforcement. And that's the way. They're not going to say we're going to, ignore the rules. We're just not going to put any funds into enforcing. Versus somebody else who say, we are going to, promote enforcement. We're going to make new rules on this, that, and the other. And so it really, people in the EPA and people who watch the EPA really see a difference. So that's important too. Sorry, I think Laura had a question.
Right now, it's so hard to find which can funnels having the construction. Like I would do in the first span of different age. So people will know that this is still what we're talking about.
Yeah. So for those online, she's talking about labeling, better labeling and requiring labeling. I agree. I will say that because we're operating in capitalism, they will say that a lot of their ingredients are proprietary and they are not required to share what's in their ingredients. Yes,
I just
sorry.
had this amazing experience the other day in the 10th floor bathroom where a student had her app out on her phone and was checking out the lotion that was in the bathroom for its green product, these apps. So labeling is important, but we also are very empowered now with all of these different apps to check in with green. You have to be careful, obviously, of how much science is in this, but people are working really hard to empower citizens to help support the situation.
Yeah.
Even if industry law, and now it'll scan the content.
That's cool.
Because this is something that I think a lot of us would want to dig into our personal community and talk about, but we may not remember all of this information. So is there a small there is a starting point which is very available, or a resource like a link tree or something that's ready for the presentation? We could have access to, and we also refer people to be prepared.
Yeah, sure. Who's it from? Oh, okay. Yes, there are, EPA has a good endocrine disruption page. CDC probably does. There's a lot on the web that would have a one pager with bullet points. I mean, clearly though, this EDC, it's huge. I mean, personal care products, pesticides, medicines, it's a huge topic, but I think they are available on the web and I'm definitely happy to share the slides. And one thing that we do, with this PACU funding is we go to communities and give talks. So I can go out into the community and talk about it too. All right. Anything else in the, I don't know what a link tree is. What's a link tree? All right, what is it?
Oh, text. It's like a it's a source, like a page that has hyperlinks to like a bunch of different things.
Oh,
The digital team looked fantastic.
Yeah, there you go.
oh, oh,
But they look really pretty and
oh, they do?
user friendly, unlike the government websites.
Right. Takes a village. Now I know what a link tree is. Anything else? All right, we're done.